This is Euclid Book 11, proposition number 5. Now, how did I draw all of this? Well, let me explain. First of all, I drew line AB and line BD. As you can see, these are perpendicular lines and they form a 90-degree angle. But the thing is that line BF and line BE also had to be at 90-degree angles to line AB. In other words, AB had to be perpendicular to BF, and AB also had to be perpendicular to BE. So what did I do? I drew this circle, and then I aimed these lines towards the circle, and that gave me my perpendiculars. Now I also had to draw a BC, and as you will notice at the beginning of the proof, BC is also supposed to be perpendicular to AB. However, later on in the proof, they changed that, and I'll show you that in just a little bit. Let me read you the proof, shall I? If a straight line be set up at right angles to three straight lines which meet one another at their common point of section, the three straight lines are in one plane. Now, this is the one plane right here. I know it's not labeled, but it is the one plane. Okay? And what it's saying here is that BC and BD and BE are supposed to be in this one plane. We'll see how that one goes. For let a straight line AB be set up at right angles to three straight lines, BC, BD, and BE, at their point of meeting at B. Now, what does all that mean? Well, AB is perpendicular, or it's supposed to be at the beginning of the proof, it's supposed to be perpendicular to BC. In this case, it's not. But it's also supposed to be perpendicular to BD and also to BE. And these three lines meet at point B. Okay, you could be a bit of a critic. It doesn't exactly match, but it technically is supposed to. Alright, let's go on. For suppose they are not, but if possible, let BD and BE be in the plane of reference and BC in a plane more elevated. So, what it's saying is that we're going to leave BD and BE here in this particular plane, but we're going to raise up BC so it's no longer in this plane. Okay. Let the plane through AB and BC be produced. Okay. So if we were going to get all creative about this, I'd create a second plane that would contain this line and this line. And this line's AB, and this line, of course, is BC. It will thus make as common section in the plane of reference a straight line. This is by Euclid Book 11, proposition number 3. Let it make BF. Therefore, the three straight lines AB, BC, and BF are in one plane, namely that drawn through AB and BC. Okay. So now we're going to say that BF here, and BD here, and BE here are all in one plane. Okay. Now, since AB is at right angles to each of the straight lines BD and BE, therefore AB is also at right angles to the plane through BD and BE. So not only is AB perpendicular to BD, and AB is also perpendicular to BE, like this, but it's also perpendicular to this entire plane. Okay. And this is by Euclid Book 11, proposition number 4. Sorry, that's my exerciser. But the plane through BD and BE is the plane of reference. So, this plane that contains BD and BE is a plane of reference. Therefore, AB is at right angles to the plane of reference. Thus, AB will also make right angles with all the straight lines which meet it and are in the plane of reference. And this is by Euclid Book 11, definition number 3. But BF, which is in the plane of reference, meets it. Therefore, the angle ABF is right. So now we're going to say that angle A, B, and F is a right angle. But by hypothesis, the angle ABC is also right. Therefore, the angle ABF is equal to the angle ABC. So when we get through with all this, we have to say that this ABF is a 90-degree angle. Then we're going to also say that ABC is also a 90-degree angle. And that starts creating problems. And not only is ABF and ABC, not only are they right angles, but they are also in the same plane. And as we know, they're not. Therefore, the straight line BC is not in a more elevated plane. Therefore, the three straight lines BC, BD, and BE are in one plane. Therefore, if a straight line be set up at right angles to three straight lines at their point of meeting, the three straight lines are in one plane. And that is the end of Euclid Book 11, proposition number 5. Thank you very much for tuning in. You have yourself a wonderful evening, and by all means, stay tuned.